Welcome to the deep dive. So, if you've been paying any attention to the business news lately, you've definitely heard the phrase AI bubble.
Oh yeah, it pops up constantly.
Right. Anytime someone mentions the, frankly, trillions pouring into AI, and it
Yeah.
usually comes with this like almost immediate kind of apocalyptic comparison to the dot-com crash.
Which, can be pretty misleading. People tend to jump straight to thinking about bubbles as like total market meltdowns. Everything just vanishes overnight.
Yeah, exactly.
But the source material we're digging into today kind of forces us to, well, step back a bit, look at it through a more, let's say, rigorous economic lens.
Exactly. And that's our mission today. We're not here to, predict the next big crash. We want to analyze this huge AI investment boom using a very specific framework.
hmm
We need to maybe forget the drama for a second and focus on the technical definition of what an economic bubble actually is.
Right. And its core, it's basically a bet that turned out to be too big, leaving you with more supply than demand. That's it.
Simple as that.
Crucially, it doesn't automatically mean the underlying thing, the technology in this case, is like useless or totally speculative.
And that's the key insight we really need to start with, I think. Even if AI is fundamentally an amazing technology, maybe a necessary tool we'll all eventually need.
Which it probably is.
Right. But the sheer scale of the investment in the infrastructure, the stuff needed to actually run it, that could still go sideways.
Yeah, the bet itself could be flawed, even if the tech is solid. It means the success of this whole AI revolution isn't just guaranteed by people wanting smarter software.
Uh-huh.
It's also dictated by whether we can successfully and, in a coordinated way, deploy this massive physical infrastructure it requires.
Okay, so that brings us right to the main problem, doesn't it? This deep structural mismatch in the timelines involved.
That's the absolute crux of it. This timeline issue is probably the single most important factor in trying to figure out the real risk here.
So on one hand, you've got the digital side moving at this, well, terrifying speed. Our sources call it the breakneck pace of AI software development.
Yeah, models get updated constantly. The newest chips are practically obsolete the moment they, hit the market.
But then on the other hand, you have the physical world.
The slow stuff.
Yeah, the slow crawl of constructing and powering a data center. I mean, these are huge physical projects.
Colossal. They involve complex permits, huge construction teams, and years, literally years of lead time before they can even, turn the lights on.
So imagine you're Meta or Oracle or Microsoft. You decide today you need, say, 3 giant new data centers by 2027.
Okay.
You're basically locking in a multi-billion-dollar spend based on technology that's going to fundamentally change what, at least 3 times before your building is even done?
That's the gamble. And it makes planning the supply side incredibly tricky. Getting clarity on what you'll actually need in terms of supply is, well, it's murky.
Why is that?
Because the demand in a few years doesn't just depend on how people use AI then.
Yeah.
It also depends on maybe some breakthrough in energy or a totally new semiconductor design or maybe improvements in power transmission that happen between now and then.
Mm.
You're essentially betting on the future of physics and basic infrastructure while you're building.
Wow. Okay, so are these bets even, like, rational, given that much uncertainty? Because the numbers involved here are just spectacular.
They really are.
If we look at the figures and the sources, the scale of these commitments, it just dwarfs almost any infrastructure cycle we've seen before.
It's genuinely staggering. And these aren't like small speculative VC bets, right?
Yeah.
These are multi-year, multi-hundred-billion-dollar commitments from the biggest players out there, established giants.
Okay, let's run through some of the numbers our sources mentioned, just to give you a feel for the scale. Oracle, for example. They've apparently already contracted $300 billion in cloud services just to OpenAI.
Just one customer, a massive future promise.
Yeah, $300 billion.
And that kind of commitment is fueling even bigger things, like Oracle, OpenAI, and SoftBank are teaming up on this joint infrastructure project, codenamed Stargate.
Stargate, right.
That's reportedly a $500 billion effort
Right.
aimed at building like dedicated vertically integrated AI cloud platforms just for their own use. They're basically building their own custom digital nations. It's wild.
And then there's Meta. Just on their own, they've pledged to spend something like $600 billion on infrastructure over just the next 3 years.
It is 100 billion.
And you see the immediate financial pressure this creates, right? Like there's this example of an Oracle-linked data center campus in New Mexico. It's already drawn down as much as $18 billion in credit from a whole group of banks, like 20 banks.
These numbers aren't just big. There's Well, they're colossal.
Mhm.
And every single dollar there is banking on the ability to generate a guaranteed massive revenue stream when that physical stuff finally comes online years from now.
Right. That's the absolute pivot point. We've got this unprecedented flood of capital pouring into infrastructure, committed years out. But now we got to flip the coin. Look at the other side, demand.
Yeah, the demand side.
Given this enormous scale up in supply, why is there still real uncertainty about how fast the demand for AI services is actually going to grow?
That's the multi-trillion-dollar question, isn't it? Who's going to actually use all that server space they're building?
Hmm.
And we actually have some decent data here. There was a recent McKinsey survey that looked into how top companies, the potential big customers for these data centers, how they're really using AI tools right now.
What did it find?
Well, the results are very mixed. Let's put it that way.
Because the general story we hear is that every major company is like knee deep in AI adoption already.
And the survey did confirm the adoption part. Pretty
Mhm.
much all the businesses they talk to are using AI in some way.
Okay.
But, and this is the crucial bit, very few are using it on any, quote, real scale.
So they're dipping their toes in?
Experimenting. Exactly. They're dabbling. They're running pilots. They're not really integrating it deeply across the board yet.
So maybe they have like specific successful projects, like an AI tool that optimizes some logistics thing, or maybe a custom internal chatbot.
Yeah, things like
But
that.
it hasn't like spread throughout the core business operations yet.
Precisely. The sources noted that AI has definitely allowed companies to do some cost cutting in specific use cases, which, is valuable,
Sure.
but, and they were emphatic about this, it is not currently making a dent on the overall business.
Wait a second. If AI is delivering actual cost savings right now, why wouldn't that alone be enough to trigger really fast company-wide adoption? I mean, if you can save money, you usually jump on it pretty quick.
That's a fair question.
Uh,
But the kind of adoption you need, the kind needed to sustain these trillion-dollar infrastructure bets,
uh,
it requires more than just shaving costs in a few departments.
okay.
It needs total, mission-critical, enterprise-wide transformation. It needs CFOs to sign off on huge, multi-million-dollar contracts for server space.
Right.
And they need to be convinced that this AI stuff isn't just, nice for cutting some costs, but that it's actually essential for generating revenue or just staying competitive across the entire business.
I get it. And proving that kind of massive return on investment, the ROI, it's a much slower, harder process.
Absolutely.
It involves validating the data, dealing with regulations, data privacy issues, integrating AI into maybe decades-old legacy systems.
All of that.
Mhm.
It takes time. So what you have is most potential customers still stuck in this kind of cautious wait-and-see mode.
Okay.
And if you're one of the infrastructure providers, one of those companies counting on those big enterprises to start buying space in your half-built data center campus next year, well, you might be waiting a lot longer than your bank loan allows for.
And that gap, right?
Mm.
Massive physical supply rushing to market, built on the assumption of demand that's growing, sure, but maybe not quickly enough. That sounds like the classic recipe for the supply-demand imbalance that defines a bubble.
That's exactly the economic bubble risk scenario. But now let's consider a big what if, just like our sources push us to do.
Okay.
What if demand is endless? What if that wait-and-see mode suddenly ends next week and the market instantly says, yes, we need all $600 billion worth of that infrastructure right now?
Right. Perfect scenario on the demand side.
Even then, our sources suggest these huge projects could still run into major problems that are purely physical.
Okay, so the risk shifts away from market economics and more towards like construction physics. Tell us about these unexpected infrastructure bottlenecks.
I think the best way to sum it up came from Satya Nadella at Microsoft. He reportedly said something quite surprising. He was more worried about running out of data center space than running out of chips.
Wow, really? That's a huge reversal from the usual thinking, isn't it? We spent decades focused on silicon scarcity, who has the fastest chip.
Exactly. And he was apparently very specific about why he was worried about the physical space.
What did he say?
The quote, or paraphrase, was something like, "It's not a supply issue of chips, it's the fact that I don't have warm shells to plug into."
Warm shells, meaning the actual buildings.
Yeah, the buildings themselves.
Hmm.
The latest NVIDIA chips might be ready and waiting, but the actual building, the shell that's needed to house them, with the right security, the massive cooling systems, the correct power setup, it just isn't ready.
And this is where that speed clash you mentioned earlier becomes really catastrophic.
Hmm.
We're not just talking about simple construction delays, are we? We're talking about fundamental power requirements being the problem.
That's a huge one. We're apparently seeing entire data centers, finished buildings, sitting completely idle because they physically cannot handle the enormous power demands of the latest generation of AI chips.
It's like buying the world's most powerful supercomputer, but then trying to plug it into a regular outlet in your house.
That's a pretty good analogy, yeah. The technology, the chips, they're advancing so incredibly fast that the infrastructure they designed maybe just 2 years ago for the building shell is now completely inadequate for the chips they're getting delivered today.
Which just highlights this ultimate reality check. You've got companies like Nvidia and OpenAI moving at light speed.
Pushing the boundaries constantly.
But the electrical grid and the built environment are still moving at the same pace they always have. Power plants, transmission lines, those things take a decade or more to plan and build.
And that massive difference in pace, that lag, it creates this vicious cycle of really expensive physical bottlenecks.
Okay, so let's think about the financial hit here for you, the listener, maybe watching this unfold. If you're one of those banks that lent, say, part of that $18 billion,
Hmm.
and the $500 million data center you financed just sits there empty and idle for 18 months,
Yeah.
just waiting for the local utility company to upgrade the grid.
Yeah, that's an enormous amount of money just
I'm
sitting
sued.
there. A sunk cost.
That capital burn rate must be absolutely terrifying for the investors. A completely finished, state-of-the-art asset generating zero revenue purely because the physical connection to the power grid hasn't caught up yet.
Exactly right. And that is the financial definition of a bad bet, potentially. Even if the technology itself is brilliant, the timing of the bet, the scale of it, was critically flawed because of the slow pace of basic physical infrastructure.
So the risk has kind of migrated, hasn't it? It's moved almost entirely from the digital world of code and chips to the physical world of concrete and copper wire.
That's a great way to put it. The risk is now physical.
Okay, so wrapping this up, what does this all really mean for you listening to this? I think the key takeaway from this deep dive is really about understanding the nature of the risk here.
Hmm.
This AI investment situation, it isn't really like the dot-com speculative stock frenzy. It's much more fundamental. It's a race against physical constraints and against time itself.
Yeah, the risk feels much more structural. It comes directly from that fundamental mismatch. We talked about the hyperspeed of software and chips versus the, well, agonizingly slow, bureaucratic, physically demanding pace of building power grids and massive construction projects.
Right.
And that gap, that difference in speed, that's where the money, potentially trillions of dollars, could get stranded, could become idle, unproductive capital.
It really is a remarkable turn of events, isn't it? For the last 50 years, the main limit on computing has always been processing power, who can make the fastest chip.
Always the focus.
And now, maybe, the biggest barrier standing in the way of AI's success isn't the code anymore, or even the silicon. It's basic physics, square footage, and amperage. How much space do you have, and can you get enough power to it?
Which leads us to a really interesting final thought for you to maybe chew on as you
Yeah.
watch these huge investments play out.
Okay.
If the electrical grid and the physical buildings are now dictating the real pace of AI adoption,
Hmm.
what does that actually imply for where future innovation and investment should be heading?
So, if the problem isn't so much the AI's brain anymore, but the physical body it needs to live in the power source, the housing,
Right.
does that mean the next multi-trillion-dollar opportunity isn't just going to be in pure software or chip design, but maybe in something like, I don't know, nuclear fusion or modular data center construction, or maybe advanced power transmission technologies?
Could be. The bottleneck used to be computational speed. Now it seems like it's shifting towards physical delivery. The next huge breakthrough might honestly be dictated more by geology and construction than by pure programming genius.
Something definitely worth thinking about. Thanks for joining us for the deep dive.
We'll catch you next time.